All right, so section 3.1, let's take a look at question number 1. It says, identify whether each of the following is a polynomial function or not. Justify your answers. Computer's freezing on me. Okay, so polynomial function, as we remember, has whole number radical expressions, right? It doesn't have any radical exponents or fractional exponents, and no negatives in the exponents. So let's take a look at number 1. I see my variable here, x, and it's got a square root in front of it. So that would translate to, if you were going to think about this as what kind of exponent is on the x here, right? That is a fractional exponent. So that's clearly not in the polynomial purview there. So that's not a polynomial. All right. This one, degree 1, that's a straight line. We've seen that on our list. So this is a polynomial. B is a polynomial. Here we have 3 to the power of x. Boy, is that okay? Can we have an exponent that is the variable itself? Well, no, we can't, because we can only have whole number exponents on variables. So x as an exponent was maybe not clearly stated, but this is an exponential type function. This is not a polynomial function, so this doesn't fit either. D has an exponent of 4. That's a whole number. So this one looks okay. Right? That's a quartic function, degree 4. This one here, the x squared looks good. The x to the 1 looks good. Oh, but this exponent of -3 doesn't look so good. So remember, that's going to be 1 over x cubed, and we can't have x in the denominator for any kind of polynomial, so sorry, that one's not going to work. And finally, this last one here, we have whole number exponents on the x's. We do have a negative number here. That's no problem, right? That's no problem at all. That just dictates our end behavior, whether it opens, like end behavior like this or like this. So that one's okay. So this is good as a polynomial function as well. Okay, you guys agree with that assessment there? Okay. All right, what's the degree, the type, and leading coefficient and constant term of these polynomial functions? So let's take a look at A first. All right, so I'm going to write up here degree and type, leading coefficient, and constant term. Okay, so for each one, we'll take a list. Take a look here. So for the first one, the degree is what? Shout it out. 1. What? Yeah? 1? Just 1? Are we sure? Okay, good. All right, looks like there was a glitch somewhere over there, but 1, okay. What's the type? So what type of function would this be? I'm assuming they're looking for the name. Linear, yeah, linear. Okay, again, we're dealing with A here first. What is the leading coefficient? -1, very good. And the constant term is +3. All right, now you don't have to graph this, but if we were graphing this, this would look something like, okay, it's going to, the end behavior is going to be here, 2, all the way over to 4, right? It's going down. We're going to have a constant is 3, so that's the y-intercept. The leading coefficient is negative, that's why it goes down. And it's linear, so basically we're going to draw a straight line through here, and that's going to be the graph. So everything lines up there. Okay, but you don't have to graph these ones. Okay, let me skip down to C. Maybe let's do C here now. So C, the degree is 4. Good. The type is quartic. Yes, it is. The type is quartic. The leading coefficient is +3, or positive, because that's the number that's on that term that carries the degree of the polynomial. And the constant, is there a number that doesn't have a variable? Yeah, +1. Okay. All right. I would point out that the polynomial, the terms may not be listed in decreasing order of the variable, which means that this one is not degree 0. This one is degree 3. So it's not always on the very first term that's listed. Sometimes they mix up the terms on you. Okay. All right. Any questions about 2 though? I don't think I need to do probably too many more there. No more surprises. Here's the constant, right? Positive 4. The leading coefficient would be negative 3 for this one. The degree would be 3. Okay? All right, I'll just do 3 with you as well here real quick, and then I'll let you go work on your own for this assignment. For each of the following, determine whether the graph represents an odd degree or even degree polynomial function. Determine whether the leading coefficient is positive or negative. State the number of x-intercepts and the domain and range. Okay, let's just take this one at a time. So for A here, so is this an odd degree or even degree? We'll just finish here in one more minute here. Okay, now the end behavior is like this. So when it spans like this, it's going to be odd. So this is odd degree. Okay, determine whether the leading coefficient is positive or negative. So remember, as it goes up from left to right, that's mimicking y equals x. So it's going to be positive, leading coefficient. The number of x-intercepts, you just count them here. This is going to be 3. And the domain and range, D is XER, always for polynomial functions. And the range, because it goes down forever and up forever, it's YER. So all possible values. Okay, so that's 3A. The bell is rang, so I'll let you guys leave there. Have a great day.